Okay, so here's our next question, number 4 of the series. The question reads, let x of s equals 3x plus 5 divided by s squared plus 10s plus 21 be the Laplace transform of a signal x of t. Then x of 0 plus is. So we have our 4 options given. Now the function given to us is the Laplace transform of a certain signal x of t. So this has to give us a clue as to what we can use. Now since the Laplace transform is given to us, we can use initial value theorem in order to find out our answer. Okay, so let's begin. Now first, we have been asked to find out the value of x at 0 plus. Now according to the initial value theorem, which is one of the basic properties of Laplace transform, so we will be able to find the initial value at a certain time. So the initial value is at time t is equal to 0 plus, right? So the initial value theorem, it states that the limit at t tends to 0 plus. So this is our initial value. F of t equals the limit of s tending to infinity, f of s equals f of 0 plus. Now this is a very useful statement. I suggest everyone note this down please, because this has come quite a number of times in the previous GATE papers. So the initial value theorem is a very important and basic property of the Laplace transform. I cannot enough, because we use this quite often in many such Laplace transform questions. So now here we will have to use this equation where the limit where t tends to the initial value of 0 plus of f of t gives us the limit of s tends to infinity, s into f of s equals f of 0 plus. So this is what we are trying to find. We are trying to find out the function at 0 plus, or the initial value. So let's see what we can do here. Now this portion, the left hand side, is x of 0 plus. We will have to find out the value. So that would be the limit of s tends to infinity, s into what is f of s? Now f of s is given to us as this Laplace transform here. So we just substitute that value. 3s minus 5 divided by s squared plus 10s plus 21. Okay. So in order to solve the limit of the right hand side of this equation here, let's take s square out common from the numerator and s square common from the denominator. We have x of 0 plus equals limit s tends to infinity, s into 3s minus 5 divided by s squared plus 10s plus 21. So to solve this, limit s tends to infinity, s squared. So when we have s squared here, what do we get? We get 3 minus 5 by s. And in the denominator, let's take s squared out as the common term. We have 1 plus 10 divided by s plus 21 by s squared. Now if we apply the value of infinity, we will arrive at the value. Now here s square cancels out, right? So that's 3 minus 0, 1 plus 0 plus 0. 3 divided by 1, which gives us a value of 3. So for this question, the initial value theorem gives us the answer of 3 at the initial value of 0 plus. So that matches option B. Well, I hope this has made sense.